All right, let's talk a little bit of chemistry. Most people hate chemistry. I'm not gonna lie, I was never a fan of chemistry when I was in college. I absolutely hated chemistry when I was in college. I took chemistry in high school and hated it then. Um, I don't know, it was just something about chemistry that never clicked for me when I was in school. But then I started applying chemistry to other advanced things. And then it didn't become cool or whatever. I appreciated it because I was able to apply it to something to help me understand something else, right? So I think that's the thing with chemistry is take chemistry slow, figure out how to apply it to something else you want to know, and it becomes an effective tool, right? You may not love it. It may not be your favorite thing for breakfast, but it's something that you can use, right? So I think one of the first things that chemistry sections and anatomy and physiology books get into is they talk about matter. And they say that matter matters, right? Matter is any substance that has mass, right? Occupies some space. But then they start talking about the states of matter. And I think the state of matter is what's really important in anatomy and physiology because you got solids, liquids, and gases. And throughout anatomy and physiology, you have to understand some basics about solids, liquids, and gases. So matter is made up of like molecules, right? And the state of these molecules can determine whether it's a solid, a liquid, or gas. If the molecules are locked together, like literally locked together like a brick, and there's minimal, minimal space in between the molecules, and the molecules are practically stationary, like they're moving, but they're moving so slow that that it's almost like they're intangible, then that's a solid. Like these walls here in the hallway, they would be considered a solid. The molecules in these walls, depending on what scientist you're talking to, are moving, but they're moving so slow, and the spaces between the molecules is so small that we consider that a solid. The space between the molecules is is minor. The amount of movement that's happening is almost little to none. That makes it solid, right? It's not something that's moving around to the extent that we can manipulate it and see it and that kind of thing. Then you've got molecules that have enough space in between them that you could put another substance into its space. But the minute you take that substance back out of the space, those molecules will then regroup and then reoccupy the space that you just created from the object that you just took out of it. And that's a liquid. That's why when you take a bucket of water, you can stick your hand down into the bucket of water. The molecules move apart to allow your hand to occupy that space. But when you take your hand back out, the molecules move back together and reoccupy that space. That is a liquid. And then once you separate the molecules apart to the point that the molecules are literally floating around, they're no longer bound together to the place where you can't get an object between them, or that you put an object between them and it rejoins. Those connections that those molecules have are so weak, are so broad and so spread out that we call that a gas. So you have a solid, you have a liquid, and you have the gas. Um, so with that being said, you got a solid, you got liquid, you got a gas. Um, and one of the most common examples that we tend to use in a science class is when we talk about water, right? Um, because water is it's something easy for people to understand and wrap their head around. And everybody knows the three states of matter of water. Usually when we see water as a liquid, that's a normal thing. It's normal to see water as a liquid. We drink water as a liquid. Water exists in our bodies as a liquid form. Most of our blood is water. And then water exists as a gas. We've seen water vapor before. Water is in the air that I'm breathing right now. That's why we measure humidity. And then we have water as a solid. That's when it freezes. It's ice. Water tends to exist in one of these three forms based on other variables, based on external variables. So one of the most important is temperature. If temperature is below 32 degrees Fahrenheit, water is going to change into a solid. If water is a temperature above 32 degrees Fahrenheit, then water is going to change into a liquid. If water is above 212 degrees Fahrenheit, then it's going to boil and we're going to end up changing it into a gas, right? So temperature has a direct effect on how, those versions of matter are going to be. Lastly, the state of matter directly affects how we use it. Now, this is probably one of the most important things right here. Water in your body is extremely important. Most people know that water is important to drink, right? Big yay. But why do we need to drink water? Most people are like, well, it's healthy and your body uses it. Yeah, but one of the most important reasons why your body uses water is as a solvent. So, three words: solute, solvent, solution. Your blood is a solution. A solution is made up of a solvent and solutes. In other words, you got some kind of liquid that things can be dissolved in, and then you got a bunch of things dissolved in it. You mix it together and it makes a solution. So your blood is actually a solution. It's got a solvent, which is water. It's got solutes in it, which are nutrients, minerals, and waste products, all mixed around. And those things are dissolved in it. And you can actually transport those nutrients and those minerals and those waste products around your body a lot easier when they're dissolved in water, because wherever the water goes, all those things then go along with it. So your blood is an excellent transportation device, and we like to dissolve stuff into the blood, and then the blood travels through your body, and so it essentially carries all that stuff wherever it goes. The nutrients, the minerals, the waste products, they go too. So we want to have water in a state of matter as liquid so that it can easily transport things for us. If you're still a little confused about the solution thing, think about Kool-Aid, right? A Kool-Aid packet of powder, that powder is a solute. The water is a solvent. The sugar is a solute. I'm going to add powder, I'm going to add sugar. Those are two solutes. I'm gonna mix them together in the water. That's a solvent. They're gonna dissolve into the water, and that Kool-Aid that I'm gonna drink is gonna be a solution. That's it. So you see that happen a lot in your body where we're like, hey, this is easy to transport from point A to point B in the body because it can dissolve into a solvent, which happens to be water. And that's it. So that's what we're going to talk about today. If you like this video, make sure you like it, share it, and don't forget to subscribe, and we'll talk about some more chemistry in a little while. Peace.